Chapter 8, Work and Energy. This lecture will help you understand work and power. Work is defined as the product of force exerted on an object and the distance the object moves in the same direction as the applied force. Work is done only when the force succeeds in moving the body it acts upon. The equation for work is the force times the distance. The units of work are Newton meters, known as the joule, and given the symbol J. Two things enter where work is done: the application of a force, and the movement of something is the result of that force. Work done on the barbell is the average force multiplied by the distance through which the barbell is lifted. Work can be done by you as well as on you. Are you the puller or the pulled? If you push against a stationary brick wall for several minutes, you do no work. A, on the wall, B, at all, C, both of the above, D, none of the above. A, on the wall. You may do work on your muscles, but not on the wall. The quantity of work done is equal to the amount of force times the distance moved in the direction in which the force acts. Work falls into two categories. Work can be done against another force, and work can be done to change the speed of an object. Work is done in lifting a barbell. How much work is done in lifting a twice as heavy barbell the same distance? A, twice as much, B, half as much, C, the same, D, depends on the speed of the lift. A, twice as much. This is in accord with work equals force times distance. Twice the force for the same distance means twice the work done on the barbell. You do work when pushing a cart. If you push the cart twice as far with the same constant force, then the work you do is A, less than twice as much, B, twice as much, C, more than twice as much, D, 0. B, twice as much. Work is force times the distance traveled. Double the distance and you double the work. Find the amount of work done by a worker lifting 225 newtons of bricks to a height of 1.75 meters. Multiply the force of 225 newton by the distance of 1.75 meters and get 394 newton meters, or 394 joules. Work is not a vector. Since force and displacement are vectors, only the force in the direction of motion is important. While the person is exerting a force on the box, the displacement is perpendicular to the displacement of the box. The force does not do work on the box. Only the component of the force in the direction of motion contributes to the work done. If the displacement is horizontal, the component of the force that is horizontal is F times the cosine of the angle theta. A person pulls a sled along level ground a distance of 15 meters by exerting a constant force of 215 newton at an angle of 30 degrees with respect to the ground. How much work is done? The force and the amount of displacement are known. If the angle is 30 degrees to the horizontal, the component of the force that is horizontal is 215 newton times the cosine of 30 degrees, or 186 newtons. The work done is that component of the force times 1.75 meters, which is 325 newton meter, or 325 joule. Power is a measure of how fast work is done. It is the work done divided by the time interval. The units of power are joules per second, or watts, where 1 watt is equal to 1 joule of work per second. Watt has the symbol W. Power can also be measured in horsepower. 1 horsepower is 550 foot-pound per second, which is equal to 33,000 foot-pounds per minute. A job can be done slowly or quickly. Both may require the same amount of work, but different amounts of A, energy, B, momentum, C, power, D, impulse. C, power. Power is the rate at which work is done. A freight elevator with operator weigh 5,000 newtons. If it is raised to a height of 15 meters in 10 seconds, how much power is developed? The force is 5,000 newtons. The displacement is 15 meters, and the time period is 10 seconds. So the power is 5,000 newtons times 15 meters divided by 10 seconds, or 7,500 newton meter per second, or 7,500 watts. A machine is designed to perform a given amount of work in a given amount of time. A second machine does the same work in half the time. Find the power of the second machine compared to the first. A, twice the power. B, 1/4 the power. C, 1/2 the power. D, no one can figure this out. Answer is A, twice the power. Power is work over the time interval. The second power is the same amount of work divided by a new time interval, which is half as long as the first. And this gives us twice the amount of power as the first. A motor is capable of developing 10 kilowatts of power. How large a mass can it lift 75 meters in 20 seconds? The power is given in kilowatts. So first convert to watts by multiplying by 1,000 to get 10,000 watts. We know the distance moved and the time. The power is the work divided by the time, but work is force times the distance moved. Solving for the force and inserting what we know yields a force of 2,670 newton. Once we have the force and realize that the force is the amount of weight that can be lifted, we can find the mass by dividing the acceleration of gravity, giving a mass of 272 kilograms.